In this lesson, we'll be verifying that certain trigonometric identities are true. In verifying whether a trigonometric identity is true, it's usually best to start with the most complicated side and try and show that it's equivalent to the less complicated side. So if we look at example A, cosine theta times secant theta, that looks more complicated than the right-hand side of the equation, which is just 1. So we'll start on the left-hand side. We know that the secant of theta is also equal to 1 over the cosine of theta. And if we multiply that by cosine theta, then we get cosine theta over cosine theta, which equals 1. So our trigonometric identity, cosine theta times secant theta, does in fact equal 1. Let's look at another problem. The secant of theta plus the tangent of theta times the secant of theta minus the tangent of theta. Again, the left-hand side looks more complicated, so we'll start there. We'll start by expanding the equation using the FOIL method. Secant of theta times the secant of theta equals secant squared theta. Secant of theta times negative tangent theta equals negative secant theta tangent theta. Tangent theta, positive, times secant theta equals a positive secant theta tangent theta. And positive tangent theta times negative tangent theta equals negative tangent squared theta. Notice that the two terms in the middle, negative secant theta and positive secant tangent theta, cancel out. So we're left with just secant squared theta minus tangent squared theta, which is carried down to the next line. Notice that this can be derived from our primary Pythagorean trigonometric identity. Recall that it's cosine squared theta plus sine squared theta equals 1. And since in our problem we've got a secant and a tangent, we know we need to either divide by cosine or sine to derive that. But if you can recognize that sine over cosine equals tangent and 1 over cosine equals secant, you're probably going to want to divide by cosine squared theta. So we'll start there. So cosine squared theta over cosine squared theta equals 1. And sine squared theta over cosine squared theta equals tangent squared theta. And 1 over cosine squared theta equals secant squared theta. This is looking very close to what we have on the left-hand side, secant squared theta minus tangent squared theta. So if we simply subtract tangent squared theta from both sides, we're going to end up with secant squared theta minus tangent squared theta equals 1. And this is in fact the identity that we're trying to prove. Pause your video now and go ahead and try this problem on your own. The left side of the equation looks a little bit more complex than the right side of the equation. So let's go ahead and start on the left side and see if we can show that it's equal to the right side. Also notice that we have two terms on the left side of the equation and only one term on the right side of the equation. So let's go ahead and combine the terms on the left side and see if that helps in the simplification process. Now, since we have different denominators, we're going to need to find a common denominator. The common denominator is going to be the product of the two denominators of these functions, cosine theta times sine theta. So we'll start by writing our problem, sine theta over cosine theta plus cosine theta over sine theta equals, and then we'll write out our common denominators, cosine theta times sine theta plus cosine theta sine theta. And then looking at the denominator of our first term, cosine theta, that goes into our common denominator, cosine theta sine theta by sine theta. If we multiply that by the numerator, sine theta, we get sine squared theta. Next, look at the second term. Our denominator, sine of theta, goes into our common denominator, cosine of theta sine of theta by cosine of theta. If we multiply that by our numerator, cosine of theta, we get cosine squared theta. Now that we have two fractions with the same denominator, we can just add them. So we have sine squared theta plus cosine squared theta in the numerator over our common denominator of cosine theta sine theta. Now recognize from our Pythagorean trigonometric identity that the sine squared theta plus cosine squared theta equals 1. So we can simplify that greatly by just substituting in 1 and writing it over the common denominator, cosine of theta, sine of theta. Now if we look at our original identity we're trying to prove, the right-hand side of the equation is secant theta, cosecant theta. It looks like we're getting pretty close. Why don't we go ahead and break up this fraction into two different terms? So we'll say that 1 over the cosine theta sine theta equals 1 over the cosine theta times 1 over the sine of theta equals, we know that 1 over the cosine of theta equals the secant of theta from our trigonometric identities, and that 1 over the sine of theta equals the cosecant theta, also from our trigonometric identities. Therefore, we've now shown that the identity is true. The sine of theta over the cosine of theta plus the cosine of theta over the sine of theta does in fact equal secant of theta times cosecant of theta.